All right, section 4.5 talks about dilations. A dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C called the center of dilation, and a scale factor K, which is the ratio of the lengths of the corresponding sides of the image and the preimage. A dilation with a center of dilation C and a scale factor K maps every point P in a figure to a point P prime so that the following are true. If P is the center point C, then P is equal to P prime. If C is not the center point C, then the image point P prime lies on CP. The scale factor K is a positive number such that K is equal to CP prime over CP. And again, they just told you earlier that that is the length of the image. Over the length of the preimage. Okay. And let's see, all angle measures are preserved. So if an angle is 45 degrees, if it's either an enlargement or a reduction, the angle is still going to be 45 degrees. Okay, so those don't change. So when the scale factor K is greater than 1, it's an enlargement. When it's between 0 and 1, we know that it is a reduction. Okay, so example 1, find the scale factor of the dilation. Tell whether the dilation is a reduction or an enlargement. So on the first one there, we have K is equal to C P prime over C of P. From C to P prime is equal to 4. C to P is 12. And if we reduce that, we'll get 1/3. And since 1/3 is between 0 and 1, we know that we'll have a reduction. Okay, for the next one, again, I don't have to put K every time, but I would put C prime over CP just to get used to that. All right, and I can write that one as 25 over 10, which would equal 5/2. All right, 5/2 would make K greater than 1, so it would be an enlargement. I would assume, ladies and gentlemen, if you put in 5 divided by 2 is 2.5. I would assume if you put that in, it'd be okay, because a dilation could be a fraction or a decimal. So I don't think they would do anything wrong there. So if Pxy is the preimage of a point, then its image after dilation centered at the origin 0, 0 with scale factor K is the point P prime is equal to a Kx times Ky. All right? And these are pretty straightforward. So on all of them, I left the original one on there for you. So graph triangle PQR with vertices P is 0 and 2, Q is 1 and 0, and R is 2 and 2, and its image after the scale factor 3. So what we're looking at here, ladies and gentlemen, is again, we're going to say that x, y, so whatever my point is, will go to 3x and 3y, so 3 times x times 3 times y. So if I take my p, which is at 0 and 2, that'll map onto p prime, which will be 3 times 0 is 0, and 3 times 2 is equal to 6. All right. Now, again, with the scale factor of 3, you know it's going to be larger, correct? So Q is 1 and 0. That'll map to Q prime, which will be 3 times 1 is 3, 3 times 0 is 0. And then our R is equal, not equal, sorry. Our R, which is at 2 and 2, will map to R prime, which will be 3 times 2 is 6, and 3 times 2 is 6. All right, so now let's just go ahead and map those ones here. On this one here, since you're doing it, you're going to be graphing some of these. So my guess is they'll just let you put the points. Hopefully they'll let you put the primes there. So we had 0 and 6. We had 3 and 0. And we had 6 and 6. And again, that was for R prime. Connect the dots. All right, now what I want you to notice, ladies and gentlemen, is that the enlargement does go by, even the side lengths are going to go by 3. So if we look here, just real quick, I'm just going to show you once. So on this one here, I go 2, right? On this one here, if you count it, there's 1, 2, 3, 4, 5, 6. So we did enlarge it again by scale factor of 3, just that side. So you can see the other two you would have to do using the quadratic formula, or Pythagorean theorem, excuse me. They're just kind of showing you that they would be the same. Okay. All right. Example 3: graph triangle PQR with vertices 4 and 6. Q is negative 4 and 2, and R is 2 and negative 6 in its image after dilation with a scale factor of 0.5. So again, we're going to say the same thing here. So we can say that xy will map onto 0.5 x and 0.5 y. So again, think about it. Your scale factor is 0.5. That's between 0 and 1. So you know that it should be getting smaller. Okay? So remember, 0.5 is half. So if we have 4 and 6, that'll map P prime to half of 4 is 2, half of 6 is 3. So Q is negative 4 and 2. All right. Q prime then would become half of negative 4 is negative 2, and half of 2 is 1. And then finally our last one, they were nice enough to just give us rectangles this time. R is negative 2 is 2 and negative 6, and that'll map onto R prime, which again, half of 2 is 1, half of negative 6 is negative 3. So let's go ahead and map those ones there. So Q is at negative 2 and 1. So there's Q prime. P prime is at 2 and 3. 1, 2, 1, 2, 3. And R prime is at 1 and negative 3. And if you can use different colors, use different colors. Sometimes they'll have you do one of them as a dashed line. But since I have different colors here, I'll be okay. And again, if not, make sure, again, when you're taking a test or something, make sure that you put the primes there, all right? Because that is our image after our pre-image, Okay, you can also have scale factors that are negative numbers. When this occurs, the figure rotates actually 180 degrees. So when k is greater than 0, a dilation with a scale factor of negative k is the same as the composition of a dilation with a scale factor of k followed by a rotation of 180 degrees about the center of dilation. But again, you're still just going to do the same thing, ladies and gentlemen. You're just going to multiply it, and you'll kind of see that this one does rotate and shrink. So it actually shrinks first, and then the negative will make it rotate. So on this one here, it says graph of triangle FGH with vertices of F is 3 and 6, G is 3 and negative 3, and H is 6 and 6, and its image after a dilation with a scale factor of negative 1/3. So again, we're still just doing the same thing. We're taking our X and Y, ladies and gentlemen, and this time here, we're going to map it to negative 1/3 X and negative 1/3 Y. Okay. So when we do that for F, we're going to have 3 and 6. And again, if I take negative 1/3 times 3, that will give us a negative 1. If I take 1/3 times 6, which would be the same as negative 6 over 3, that'll give us negative 2. Same thing for G. They made us nice numbers this time. So negative 3 and 3 would map G prime. Again, negative 1/3 of 3 is negative 1. And negative 1/3 of negative 3, negative times a negative is a positive. So that would give us a positive 1. And then our last one, H of 6 and 6, is equal to H prime. And again, that if we worked it out, we'd get negative 2 and negative 2. All right, so if we mapped all those, so plotted those points, I'll have negative 1, negative 2. So there's my F prime. I would have negative 1 and 1. There's my G prime. And my H prime will be at negative 2. Go down negative 2. And that's my H prime. Stop. And again, it's not perfect, but look again here. It flipped. It rotated and it shrunk. It actually shrunk first and then it rotated 180 degrees. So you should be able to see that. So again, we can still do compositions with rotations also. All right, and then the last one's a word problem because you'll see a word problem every once in a while. So you're using word processing software to type the online school newsletter. You change the size of the text in one headline from 5/10 of an inch tall to 1 and 25 inches tall. What is the scale factor of this dilation? So again, our scale factor is going to be the size after dilation. Or our pre-image over our image. So size before dilation. Now also think to yourself, ladies and gentlemen, it is going to, you made it bigger, all right? So you should have a K that is greater than 1. So on this one here, we have 1.25 inches over 0.5 inches. All right. So when I have a scale factor, ladies and gentlemen, what you should notice, your dimensions are going to go away. All right. So now, if we do this, I'm going to kind of show you some fraction stuff here. So remember, 1 and 25 hundredths, well, 0.25 is 1/4. All right. And then on the bottom, 0.5 is 1/2. Now remember, I want to multiply, I want a mixed number here. So I'm going to take 4 times 1, and I'm going to add it to that one there. So on the top, I would have 5/4. On the bottom, I would have 1/2. Now remember, on that, it's saying that I have 4.5/4 divided by 1/2. All right. And remember, we don't divide by fractions. Instead, we multiply by the reciprocal. So I'll have 5/4 times 2/1. 2 and our 4 will cancel. So we'll get 5/2. So k is equal to 5/2. Now I put that because that was the answer in the book on my example. But remember, I think you can either say or 2.5. All right. So just remember, I just did all of this part right here with the fractions just in case. All right, but I'm pretty sure I'll let you do either one. So good luck.